It's a freezing day in central London, and the one thing that's keeping me going through the day is planning my next trip somewhere hot, preferably somewhere tropical. But the one thing that drives me crazy in such places is the mosquitoes. I'm here at the school to go and talk to Stanczyk, who's been doing research into mosquito repellents and how effective they really are at keeping the mozzies away. What got you into working with mosquitoes? It doesn't sound like the most glamorous research area.
I think it's very glamorous. I've been told that mosquitoes are very sexy creatures to work with. But no, I never really planned on working with mosquitoes. And certainly when you're growing up and you're at school and they say, well, what is your plan in life? The mosquitoes didn't really enter into that. But I did some work experience in a short job working with mosquitoes, and it ends up being so interesting, the things that you're trying to find out, what they find, like attractive smells to trap them, new repellents, and all the different ways that they react with and interact with people. It's fascinating, so that's what got me into it, really.
Can you give me some examples of how the work you're doing here will actually make a difference to people?
All right, so I do a lot of work looking at different repellents for mosquitoes. And obviously people, especially people travelling abroad from England to other countries, but also people that live in the countries at risk of diseases transmitted by mosquitoes. Repellents can make a really big difference to their ability to protect themselves. In the end, the best way of not getting a disease transmitted by mosquitoes is to just never be bitten. So really looking at what makes these repellents work and how we can make them better is going to theoretically be protecting people from diseases and saving lives. So.
That really resonates with me because I travel a lot and I always use DEET, and ever since I discovered it a few years ago, it's really changed my time out in tropical countries. But you're working on DEET at the moment, aren't you? Do you want to tell me a little bit about that?
I am working on DEET. It is absolutely the best repellent out there, and you should be using it. As you're saying, it makes a really big difference. It's the most effective repellent there is. My work is sort of looking at the ways we can discover exactly how it works, and also how well it works. So the work that I've been doing is looking at if there's any way in which mosquitoes can become insensitive to DEET and it can stop working as well. And what we've found is that in some cases, the mosquitoes that we have here in the lab, for example, can actually stop being repelled by DEET. Now that doesn't mean you should stop wearing DEET, because when you're out in other countries it will absolutely protect you. But it does mean that we've become aware of potential problems and can look at ways to solve them before they start cropping up out in the field. So what we did was take mosquitoes and expose them to DEET, basically put some DEET on my arm, stick my arm on the cage and see whether or not they were repelled by it. And the first time you do this, they're almost all repelled. And then you give them a few hours and you try again. And the second time round, even the ones that were repelled the first time would suddenly be a lot more interested, would come and try and bite me. So it was those mosquitoes I'd sort of separate out, and then I could compare the responses of those ones to the ones that were still repelled. And the way I did this was to look at the responses of the actual antenna of the mosquitoes. Now, the antenna are what the mosquito uses to smell. So it's how it tracks you down out in the wild. It follows the smells of your sweat and your breath, homes in on you, and then bites you. So one of the ways we can look at how they detect the smells is called electroantenography. And basically the way we do that is hook up the mosquito's head and antenna to an electrical circuit so that we can see every time an electrical signal passes from their antenna to their brain, it shows up as a little blip on our radar and says they're recognizing whatever smell you're passing through them. And that's a way you can tell what chemicals are relevant to them and what's important. So if we took these mosquitoes that weren't repelled by DEET anymore, hooked them up to our system so we could track their antenna, and then we passed attractive smells over them, we found that they just literally weren't detecting them as well in the antenna. The receptors in their antenna weren't picking up the chemicals anymore. So it looks like there's a change in the receptor that's stopping them from detecting the DEET as well.
I do have to ask you this. You had to stick your arm in a cage full of mosquitoes.
Well, I do on a regular basis, but actually for this experiment I just had my arm on top of the cage. So they were probing futilely at the mesh, desperately trying to get to my arm, which was about a centimetre away.
So you didn't actually get bitten?
No, not in this case, but we do a lot of other experiments here where I do have to sacrifice my arm on the altar of science. What this work sort of indicates is that, potentially there may, at some point in the future, be some problems with the repellents that we have that we need to be aware of in advance. You know, possibly we can use this information to alter the repellent DEET to make it more effective. It may also help us in finding new repellents, because we'll know, you know, if they're able to overcome certain things, what they wouldn't be able to overcome. So, you know, even though the repellents are working fantastically at the moment, what this tells us is maybe how to prevent problems cropping up, and how to alter things for the future to make them more effective.
So all of a sudden the mosquitoes started making a sound that was so loud that I thought one of the lights was about to blow. That sort of sound makes you feel so edgy, doesn't it?
Absolutely. And it's worst of all in the dark at night, isn't it?
If you've got a single mosquito in your room and you know that it's just about to bite you as you're dropping off. When you were describing putting your arm near the cage, I wondered how important it was that it was an arm and not just anything with some DEET on it.
Okay, well, the first experiment I did was with an arm. It's the very standard way, because obviously mosquitoes are attracted to people, to find out if a repellent is working or not. But having found out that they would change their behaviour and still try to bite with the arm, we then tested it with other things. So we tested it with just a heat source and no arm at all, to tell if the temperature was enough to do it. And they still changed their behaviour. And then in the end we tried it with nothing at all, nothing attractive, nothing that they would like. Just, you know, a piece of, DEET on some tights in the end. And they still changed their behaviour after being exposed to the DEET. So it was almost as though just having the DEET there, getting used to it in a way, it could be changing their receptors, maybe saturating them, maybe they were becoming habituated to the odour, so they didn't respond to it as much. But certainly in almost any experiments we do the human arm first, just because we know the mosquitoes are always interested in human arms, so it's definitely our first test.
How long do you think the effect lasts? So if a mosquito went back the following month, would it still be less sensitive?
Wow, the following month, that would be a very exciting experiment.
Do they even live that long?
We do have some that manage, but we take great care of ours, you know, whereas out in the wild they have quite a risky lifestyle. Well, the experiment that I did was 3 hours. We're really interested in testing what you're saying, in doing it over longer time periods. And we're about to start a study to look at that, to see, you know, a day later will they still respond the same way, and even longer perhaps. So it's a really good question. It is something that we're absolutely interested in knowing. And one of the other things is we did this study with Aedes aegypti, which is the yellow fever and dengue fever mosquito. But we'd also really like to look at it in Anopheles, which spreads malaria, in other species of mosquitoes, and really find out how far this effect can go.
So in terms of the next steps for your research, is it really just finding out how prevalent a problem this is? Are there other questions that you want to look at? That's interesting too. It is a case of finding out how prevalent it is, how much it varies between the mosquitoes that are out there, how long the effect will last, hopefully not for a month. And another thing is how great a concentration of DEET is needed for this to still happen, you know. So I tested this with 20% DEET. But a lot of repellents can use higher percentages of DEET out in the field. So we'd really like to test those, because it's possible that, you know, at the levels that people are using, this wouldn't be an issue. So we'd like to look at that and find if there's a cut-off point at which they can't change their behaviour anymore, at which the DEET is just too repellent, basically.